Welcome to the problem section for the ambiguous case. I'm going to do again a small number of problems, 5 of them total. Pretty much wrote down all the information. I got myself already drawings for the first 3 problems here. Anyway, here's the first one, which says for the triangle ABC, solve for the angle B, given the information that the angle A is 30 degrees, the side B is 40 feet, and the side A is 10 feet, which you can see here, except that I don't know how far A goes down here. I'll talk about that drawing in just a moment. So I'm going to use this equation here. So sine A equal over side A equals sine B over side B. I'm going to plug in the numbers, which are 30 degrees. Here's a given 10. That's actually the angle we're supposed to determine. And B comes out to this 40 degrees. Now I'm going to plug in numbers. In fact, I believe we can do that in our heads. So I'm going to do this here. Sine B times, sine B equals sine of 30 degrees over 10 times 40. So 40 times fraction sine of 30 divided by 10. There we go. That comes out to, well, sine of 30 degrees is 1/2. 40 over 10, of course, is 4. 4 divided by 2 comes out to 2. And then, in order to get the angle B, we take the inverse sine of 2 and we know that that is not possible undefined. Okay, what happened here? Well, for one thing, we do come up with an impossibility here. We can't take the inverse sine of 2. But when we look at the triangle, what happened here is that we're given an angle of 30 degrees, and that's kind of the way it looks like. It's not absolutely to scale, but it's relatively close what I did here. So we have an angle of 30 degrees. We have a side B of 40, and then the side A of 10. No matter where we try to point it at, we don't know the angle at this point here. It's never going to reach that baseline, the third side of the triangle. And so graphically, that's what happened here. Algebraically, what happened is that we're not able to take the inverse sine of a number that's larger than 1. In any case, we have no solution. And then there's yet another explanation for angles A of less than 90 degrees. If the side A is smaller than the height A, than the height H, then we come up with a triangle that cannot exist. Okay, let's do the next one. I think I'm going to copy this here. In fact, I think I will just copy all 3 of these. There we go. Okay, so next one again, find the angle B. This time, or again, we have angle A equals 150 degrees, side B equals 30 feet, side A equals 10 feet. So we're going to plug in the numbers. The only thing that changed from the last problem is the angle of 150 degrees. We solve for B. So 150, and I guess we have 30 here. Sine of 150 is also 1/2 times 30 over 10, which is 3, of course, comes out to 1.5. And now we do the same argument as we did before. That we try to take the inverse sine of 1.5. That is not possible, undefined. And we have, again, no solution. We look at the second triangle here. Here's what happened. The angle is larger than 90 degrees, so it's an obtuse angle for this triangle. And then we're trying to extend A, but the side A has to be at least as long as B, the side B, in order to get to the baseline side C. And since that's not the case, we have shown it graphically here in this drawing as well as algebraically. We're not able to take the inverse sine of 1.5. Okay, the next one. See, again, I'm going to copy all of this here so I don't have to write down as much, and then paste the new information in there. Okay, says that we have an angle of 120 degrees, side B of 20, a side A of 30. So doing the algebra, we're going to have 20 over 30. Sine over 120 comes out to the square root of 3 over 2 times 2/3. So I'm going to write here. Oops. 2/3. Whoops. 2/3 times the square root of 3 over 2. 2's of course cancel. Square root of 3 over 3 is the 1 divided by the square root of 3. Or we just leave it, I guess I just leave it as the square root of 3 over 3. Okay, let's see what we come up with here for the angle B. Again, I'm going to use this calculator given by the computer. That's a big gray box here. Square root of 3 over 3. .577. We know that by having memorized the tangent of 30 degrees. Here we are taking the sine of the inverse sine of that number. So I'm going to do that. Come up with 35 degrees. This in this case that doesn't have anything to do with 30 degrees or tangent of it. I just remembered the number 0.577. Okay, so this one here is 0.577, and in this case we come up with a nice number, and that was, just double checking, 35 degrees. There we go. In this case we have the first angle is obtuse, and we again can see that from the drawing. I think my drawing is way up there, so I'm going to pull it down here temporarily. There it is. So here we have a large angle, 120 degrees. We have a side B equal to 20, and we have a side A that is actually longer than the side B, and therefore it will reach the baseline side C. So therefore it should work out. In fact, that angle B comes out to 35 degrees. In this case, we have one solution. We could possibly look at, well, you know, we took the inverse sine of 0.577. We could of course come up with the reference angle of 35 degrees. That means in the second quadrant it exists as well as a positive number, the 0.577. So we would come up with an angle of 145 degrees, but that cannot be, our angle here cannot be 145 degrees because it and the angle A here of 120 would by far exceed already our total of 180 degrees for the triangle, and so therefore we can only have that one solution for 35 degrees. Okay, a couple more examples. So here is finally the ambiguous case. Where we have given, let's see, maybe I do copy this down here. Let's see what I have. Oops, okay, didn't want to do that. Alright, here we go. Finally. Okay, so again we're going to use sine A over side A equals sine B over side B. So we're going to plug in the numbers. Sine of 30 degrees divided by 6 sine of, oh, that's what we're supposed to figure out, b divided by 12. There we go. Use these numbers. So we have a 12 right here. 6 right there, and sine of 30 degrees. 12 over 6 is 1/2. Oops, not 1/2. 2 over 1. Sine of 30 degrees, that is 1/2. There we go. 2 times 1/2, of course, comes out to 1. So we're taking the inverse sine of 1, and we come up with 90 degrees. So what we have here is this little triangle on the left here, which actually comes out to a right triangle, where we have just determined that the angle B right here comes out to 90 degrees. We have 30 degrees over here. Yeah, so again we get one solution because there is no other solution for inverse sine of 1 anyway. Okay, and the last problem. Oh, this is where we finally get to the ambiguous case. Okay, let's see. Again, I'm going to see that I paste all the information in here. So again, sine A over A and so on. This time, angle 60 degrees. The side A is 16. Sine B divided by 18. There we go. In order to solve for sine B, so it's 18 divided by 16 here, and then times sine of 60 degrees. Okay, 18 over 16 is the same as, okay, maybe that's 18 over 6, and I can also write 9 over 8. Either way, times the square root of 3 over 2. Let's see, what can I do here? Not much really. I might as well just write it as a decimal number. So again, here's my graphing calculator on the side. I'm sorry, the computer's calculator on the side. Times, let's see, equals 0.974. 0.974. Double check that. Yep. Okay. So take the inverse sine of 0.974. Should be pretty large, 76.97, so around at 77 degrees. 77 degrees. Well, that's a reference angle. What about the other angle that will come out to be prime, perhaps, equals 103 degrees? In the last exercise, that didn't work, because here, oops, not in this exercise, but in the one before, here it didn't work. The angle B prime here would be 145 degrees. Doesn't work. Because the RE angle given A plus B prime in this case is already greater than 180 degrees, as you can see. Here it works. The second solution works. Because angle A plus angle B prime is less than 180 degrees. As you can see, 103 plus 60 is just 163, so we have an angle of 17 degrees for the side for angle C, so we will have two solutions. And when we look at the drawing here, we come up with here the reference angle 77 degrees is right here, right there, with a triangle of B equals 18, A equals 16, angle A of 60, and an angle C here apparently of, how much is that, 43 degrees. Well, there's a second triangle that exists, also with side B equals 18, side A equals 16, angle A equals 60 degrees, but an angle C of 103 degrees right here, and a very acute angle of for C of just 17 degrees. So for these conditions here, that's when we get two solutions that two angles that we have now calculated are actually less than 180 degrees. And with that, I'm finishing this problem section for the ambiguous case for the law of sines.